Right, good afternoon, boys and girls. Welcome to the party. And we are going for a bush class today. I'm stuck at Tula at the moment, and we're going to get straight into the class. I'm going to start sharing the screen, and away we go. All right, so this week we're starting with set Artiodactylans, which otherwise known as Artiodactylans. The reason why we include the word set is for cetaceans, because we lump cetaceans in with them as well. Okay, so the book of the week, as always, is every week I do a book, and this week is Evolution in Minutes by Dr. Darren Nash. The Evolution in Minutes is part of the In Minutes series, which are around 200 Rand a book, available exclusive books and bargain books. And well worth getting. I own a numerous number of these books, and numerous number, I don't know what that was. And yeah, it's I firmly encourage anyone to get these books. It summarizes very complex ideas into simple concepts. Each page is a few paragraphs, and explains things in a way that you can understand at a layman level. And I always love these books just for referring back to quick ideas, especially instead of slogging through large textbooks and trying to remember things. A lot of the concepts are just one paragraph and neatly summarized. Okay, so what is an artiodactyl? Artiodactyls are mammals, obviously, because we're sticking to mammals, and they are animals that walk on paired toes or cloven hooves. They're even-toed ungulates. Okay, so many are directly linked to grassland ecology, and they have a coevolution with many grassland species. And they include ruminants. These are animals with complex digestions, and many have lost their canines and incisors. The dentition varies greatly, as do the diets. You have everything from strict herbivores to carnivores in this group of animals. And most of our domestic animals are artiodactyls: camels, cows, sheep, pigs, goats. They're all artiodactyls, not horses, obviously. Okay, so going back about 46 million years, we're going to be looking at a small little animal called Diacodexis. And it was a small animal, about 50 centimeters long, and it walked on effectively tippy toes rather than a flat palmate foot structure. And it would look quite similar, in my opinion, if you want to use your imagination, to a bit of a cross between a kangaroo and a rat. But these were the ancestors of all the modern artiodactyls. So everything from your cows through to your whales and everything in between, from camels and pigs, all their roots can be found in these guys over here. Diacodexis had a pretty long run from about just under 40 million years. And initially the theory was that we thought that this animal started to evolve a smaller foot structure for making greater and greater strides, basically allowing it to run faster than its predators. So the set Artiodactylans include the Tylopods and Suidae, which are two different groups, which are camels and pigs. The ruminants, which are bovines and deer. Bovines are anything with horns, so that's anything from a goat to a cow to a sheep, antelope. They're all part of the bovids. And deer are different because they have antlers, not horns. They shed their antlers annually. Whipomorphs and cetaceans are hippos and whales, two separate orders, and they are related to each other. And okay, so these are the even-toed ungulates. Artiodactylans, very similar to us in many respects, except that their toes have changed slightly. They've absorbed the fifth finger over here, or actually the first finger, first digit, and they're left with the remaining four from 2 to 5. The number 2 and number 5 are receded up the body, so all that they're basically standing on are their two little tippy toes like this, and you'll have at the back, I can't really draw like that, but you can imagine they would have at the back over here their little dew claws, as they call them. Now, pigs at the back of their trotters, you can see them clearly, and with antelope you can see them less prominently, but with cattle you can see them quite clearly as well. And they come in many shapes and forms to greater or less extents. So we're going to first be talking about the Tylopods, and the Tylopods are a suborder dating back over 55 million years. Their oldest fossils date back to around 50 million years ago, give or take. And the word Tylopod means a calloused foot. They don't have hooves. Now, initially there were many families. They originated in the North Americas and they diversified all over the world. And today there's only one living family, the Camelids, which include the true camels and cousins of camels. And Camelids are not ruminants, rather they have been called pseudo-ruminants. They have a 3-chambered stomach. And all modern camelids they lack keratinous hooves. So they have a fleshy pad around their skin, much like we have fleshy pads around our digits. And the foot is made up of 2 toes covered with callus skins and then little nails at the end. Most modern camelids have remained relatively unchanged for millions of years, and like other fossil creatures, ancient creatures, we refer to them as living fossils. Now, what's interesting is that camelids are induced ovulators. They don't go into normal ovulatory cycles. They have to mate with the male in order to induce ovulation. So sometimes in the Middle East, you actually see camel riders or camel farmers trying to push their camels onto the females. Okay, so there you can see the foot structure over there. It doesn't have hooves. So this is an Arabian camel skull. Okay, and you can see over here, it's still got some of its incisors and canines, but it's quite a strange face. It's got this really long rostrum over here, which would actually extend all the way out to over here, including the cartilage. And it actually wants to have an important sense of smell, partly for picking up for its food in the desert and arid regions where it's hard to find food, but also to help with cooling, which we'll get to in a minute. As again, with most of these animals, they have quite robust jaws. This is the body of a camel, fairly hardly built. The shoulder blades are quite powerful, the neck is quite robust, heavy skull, heavy ribs, and quite a strong backbone to bear a lot of weight. The animal is quite heavy. So camels. These are limited to Central Asia and the Arabian subcontinent, and these include the Bactrian camel, the wild Bactrian camel, and the Arabian camel, otherwise known as the Dromedary. Okay, the wild Bactrian camel tends to have slightly more spiky bumps than the domesticated version. Now, the camels have oval-shaped blood cells as opposed to circular, like most mammals, and they're also a lot thinner in number in the blood. Ours are quite dense. Camels tend to have very low numbers of red blood cells. And this helps with the blood flow even when they're dehydrated. So when they lose moisture and they've got actually more coagulated blood, it still flows very smoothly throughout the body and they don't suffer from dehydration. They're also able to store about 1 gram of water for every hump in their hump for every gram of fat. So they can store a lot of water in their body, a lot more than we can. And camels can able to lose about 25% of their body weight to sweating and water loss, where we can only lose anything up to 8%, in some species up to 14%. So they're very efficient at water loss. And like most desert living animals, they have a Rete Mirabile to help with the blood cooling. So here you can see the camel's blood cells compared to human blood cells, significantly less dense. And a Rete Mirabile is a series of capillaries that pass through the nasal cavity over here and basically help with the breathing, helps cool the blood cell. If you look over here, the nasal cavity over here just has arteries and veins going into the brain, and most of the breathing doesn't actually facilitate any cooling. Whereas over here, they have quite a complex set of capillaries around the Rete Mirabile over here, and this actually helps, as the animal breathes in and out, that blood is broken into, rather than one big thick artery, is broken up into a series of thin capillaries passing through the area, and it cools down much quicker, helping the brain cool down. Now, a lot of animals from springbok have this, ibexes, certain species of ibex have this, gemsbok in southern Africa, and the oryx in Saudi Arabia also have this as well. So it's evolved independently several times amongst numerous animals. Now, sorry, not the Bactrian animal, the Arabian camel is the dromedary. So wild dromedaries have been extinct in the wild for over 2,000 years, and there are only domestic strains alive today. There are no wild strains that have been domesticated into extinction. Australia has a substantial infestation of feral camels, and that pose a problem for local ecology, but as usual, human emotions get in the way, and people say, oh, shame, the poor camels, and they let their emotions override the actual impact on ecology, like we talked about with cats. And humans' emotions, although well-meaning, are sometimes one of the biggest problems that we create for ourselves. Domestic camels, like horses, have been heavily utilized by humans in desert conditions for over 3,000 years. Entire kingdoms have risen and fallen on the backs of camels. We seem to see them as clumsy and cumbersome, but actually they're highly efficient desert animals. They're fairly smart and they're tough as nails. So they're a great domestic animal in that respect. So camels have been used extensively in desert battles by humans due to their hardiness, their low logistical cost, and superiority in crossing hard terrain. Being flat-footed, they're better for getting over mountainous terrain and also over rocky terrain, unlike horses. Horses break their legs regularly on rocky terrain, and camels don't have this issue. They're also more robust. They don't run as fast, but you're not looking at speed, you're looking at durability. They use less water and they eat less food as well, so they're better than horses. Horses, on top of this, are easily spooked by camels in battle. And this has been used numerous times to great effect in the Mediterranean and Arabian conflicts. One of the greatest battles that I know of personally, from just reading about, and that's why I was inspired by this, was the Battle of Crassus in 547 BC, when Cyrus, the king of Persia, actually invaded Lydia, and they were outnumbered 6-1. But Cyrus actually realized that the camels were very, very effective at chasing horses. So he lined all his baggage trains with camel guards, and he put camels at the forefront of his army as well, and just basically charged the horses. The horses spooked, 6-1 they ran, and they completely thumped the Lydians, and the rest is history. So, on top of this, Persians could also carry 2 men on a camel's mount, be mounted on a camel, as opposed to 1 on horseback. So again, you could basically field twice the number of men in battle. Much later, the Romans realized that the camels were far more effective at patrolling the desert aspects of their empire than horses, so they actually formed the Dromedarii, which were Roman legionnaires specialized at fighting on camelback. When the Moguls invaded India, which were a Mongolian offshoot of they were an Indian offshoot of the Mongolian Empire, and they took over parts of India, they used camels to invade northern India because they were actually far more effective than the horses, and they could also work wonders against the elephants. Apparently, elephants are also quite spooked by them. The British learnt during the North African campaigns, and also World War I and World War II, that camels were more effective than horses, and the British had a well-functioning Imperial camel corps in Egypt right until the 1940s. So, we're not only going to talk about camels, we're going to talk about the other camelids, which are South American camelids, which are specialized for living in high altitudes and in colder climates. They don't have a hump, because they don't need it, or other attributes surviving desert conditions. They are selective grazers and important nutrient contributors to high altitude biomes. Much like the fynbos in South Africa, the Andes Mountains are very low in nutrients, and a lot of the nutrients come directly from the animals, they don't come from the earth itself. The soil is actually very, very poor quality. And it's extremely saline, this quality of the water in that area, and because of this, the camelids in this area have evolved an ability to consume water that's extremely high in salinity and actually survive off in limited quantities of salt water, like seawater. So the first we can talk about is the Llama genus, and these are limited to South America, as they all are. They have no dorsal hump. The one is the domestic llama, Llama glama, great name. This furry fellow over here, fairly aggressive from what I hear. I've never had the good fortune of meeting one. And the other is the guanaco, which is Llama guanacoi, which is limited in numbers. There's only a few thousand pairs left in the wild, and purely because of hunting. The meat is tough and apparently terrible, and just sport hunting has eliminated their numbers. The Vicugnas are the other genus, and they're limited to South America. They have also no dorsal hump. The one is the alpaca, far more friendly than the llama. And this little fellow over here, also well known for its fur. And the Vicugna is there's only again, I think 2,000 or 3,000 pairs in the whole of the Andes Mountains. And same problem, the Spanish eradicated large numbers of them, and only in the 1960s they were protected, and their numbers are gradually recovering. I think they were down to a few hundred pairs in the 1960s, and now they're up to a few thousand pairs. So the numbers are recovering, and hopefully we'll see previous numbers restored. Okay, so one of the things about camels is that we don't realize that camels actually graced the earth in anywhere you had a desert area. And one of the most interesting was the Syrian camel, which went extinct 100,000 years ago. These aren't even real fossils. These are semi-fossils. They are still calcium carbonate, and they're just baked into sand. Now, the Syrian camel was about 3.5 meters tall, and he was a rather big boy, and we assume just changes in climates. Humans have no indication of having wiped them out, and a lot of species go extinct because of humans, but this was probably attributed just to climate change in Syria, that region. Now, how did camels get from the Americas? Remember I said to you that camels evolved in the Americas and migrated into the Old World. They passed through an area called Beringia, and the Beringia is a straits, the Bering Straits, as I'm sure you know, which connect Russia at the Chukchi Peninsula and Alaska. There are Eskimos on both of these sides as well, so Russia has Eskimos as well. A lot of people don't realize this. And the Chukchi Peninsula and the Alaskan Peninsula are only a few 100 kilometers away from each other, and during glacial periods, the ocean levels of the earth are much lower, about 100 to 200 meters lower, depending on where you are, and this entire area is actually grassland. So you can walk from Russia to America through the grasslands over here. And this is how animals migrated back and forth. That's how the lions got into North America. That's how the cheetahs came across from North America. That's how the various animals crossed from backwards and forwards, and how the elephants got into America as well. So these, during glaciations, the sea levels would drop, species would be able to migrate, they'd be isolated for tens of thousands of years, and they would radiate into new areas of evolution. And humans likewise came through here about 15,000 years ago. That's how the Native Americans came through from Asia into the Americas. The Native Americans are Asian in appearance, and you could consider them as the Asian gene pool. So we're going to talk a bit about the Great American Extinction. A lot of people love this whole idea of the Native Americans living with nature. This is a fairly new concept, like we're living one with nature now. We're trying to. We have nature reserves. For the best part of our history, we blasted out everything that we could catch. And Native Americans arrived in North America about 15,000 years ago. And within a few hundred years, every large plains predator, except for wolves, had been driven to extinction. The North American lions, the North American cheetahs, the North American direwolf, all these other predators that I'm not going to go through the whole list. We'll do an extinction class one day. Driven to extinction. Likewise, the vast majority of large browsers and grazers followed as well. The North American rhinos went. Various species of bison went extinct as well. The North American camels went extinct. The mammoths were hunted to extinction as well. Not the mammoths, the mastodons. The North American mastodon, which was about 4 meters tall, and the Columbian mastodon, which was about the size of an Asian elephant, went extinct around 9,000 years ago. Hunted by humans, to not die of their own accord. So this nonsense going around with the North Americans being one with nature, it's a trendy fashion concept, but it's not true. Humans are bastards wherever we go in the world. Okay, South America suffered a similar extinction around 9,000 years ago. When humans started migrating into South America around 9,000 years ago, another great extinction followed. Various species went extinct. The giant armadillo, which was an armadillo the size of a hippopotamus, was hunted to extinction. The giant sloth was hunted to extinction, which was a sloth about the size of a rhino as well. Humans hunted them out. They could catch them, they killed them. As simple as that. And what's left in these areas today is what the humans couldn't catch, or learned that they were just not worth catching. So these are the three key migrations. The first migration came through around 15,000 years ago, migrated south into the Americas, made their way downwards, and gradually into the South America. The second migration came through and colonized the central plains of America. Much later, I think around 8,000 years later, 8,000 years ago, the final wave of Native Americans came through, realizing the entire southern parts were occupied. They stepped to the north and they became the Eskimos throughout Greenland and northern Canada. So those are the camelids. We'll talk about Suina now. So we're going to look about, Suina are simply just pigs, simple as that. If it's a pig, it's a Suina. If you look at the pig, they're quite different to other pigs. They have quite a robust, heavy skull. The skull is quite wedge-shaped, indicating that it has a digging function. Unlike the camel, the majority of the rostrum is not cartilage or flesh. It's solid bone because they're a digger. They have a very long rostrum for smelling, very highly developed nasal cavity. They've got quite pronounced grinding molars, also canines and sizes as well. Big eyes, and the very, very large zygomatic process, again, for just that inherent strength, and that flat back, okay, to create that solid impact structure that they want for digging and snouting. So Suids are simply pigs and all their relatives. They're generally omnivorous to greater or lesser degrees. And unlike other Artiodactyls, they have a simple sac stomach. Males have a corkscrew penis, and he actually has to wind his way into the female's vagina, and it can get lodged in there for quite a few hours. And they can be divided into Old World and New World pigs. The Old World is Africa and Asia, and the New World is the Americas, North and South America. Just that simple. So Suids, which are the Old World pigs, there are 18 species, not that diverse, 6 genera. They are highly opportunistic omnivores, but herbivory comprises the majority of their diet. And they're more robustly built than other Artiodactylans, owing to their burrowing and digging-based lifestyle. Some burrow more than others. The top canines in the Old World pigs tend to grow outwards rather than down. So you'll see with warthogs, if you're from South Africa, you are well affiliated with warthogs, and you see them growing outwards. Okay, so we're going to look at the sus. There are 8 or 9 species, depending on which scientist you talk to. The first is the Filipino warty pig. This fellow over here, slightly more elongated snout, but not too different from most of the pigs you and I know and love. The wild boar, the ancestor of all modern pigs, this little fellow over here, and much like humans, depending on where they are in the world, they're lesser or more furry. If you go to the wild boars in India, they're far less furry than the wild boars of Sweden and northern Germany, even though they're the same species. Like if you take a Scandinavian and a Greek, they look quite different as well. So there's a lot of divergence in the appearance of the species. And of course, the Bornean bearded pig, which is this handsome fellow over here from Borneo. Porcula, which is a pygmy hog, only about 50 centimeters long, so about as long as your forearm. There's only one species. He's limited to the lower mountains of the Himalayas. A firm favorite of many of the eagle species there, and leopards and snow leopards. Unfortunately, because of the hunting encroachment of humans in the area, they've been driven down to just 600 individuals known. Okay, so they estimate there's less than 600 known, and they are trying to rehabilitate and recover the numbers, but the species is on a downhill slide, and it's going to take a lot of conservation efforts to bring them back. They're very cute, and they're not even on the endangered pet market at the moment because there's so few left. Phacochoerus is the giant forest hog, an absolute monster, limited to the forests of Central Africa. Really meaty, ugly boy, but quite cute in his own way. Phacochoerus, which is just two species, the bush pig, this fine fellow over here, well known throughout Southern Africa and Central Africa, and the red rubber hog. Okay, very cute little fellow. And again, also this fellow, much like the giant pig, limited to the forests of Central Africa, a forest specialist. A lot of these pigs are forest specialists, simply due to the fact that a lot of their food is buried below the ground. Phacochoerus, which is the common warthog, which is Phacochoerus africanus. He tends to be a little bit bigger than the Somali warthog, this guy over here, who also has slightly smaller tusks and is not as robustly built. But on casual appearance, even an expert will have a hard time telling them apart. Genetically, they are different. They're not able to interbreed with each other. And the common warthog is just more robust and more widespread. The Somali warthog is limited to Somalia and Ethiopia. Also known as the desert warthog. All right, so Babyrousa. So you'll be looking at Babyrousa, which is a small group of pigs that are limited to the Malaysian and Indonesian islands. There's only 3 species. The first is the Moluccan Babyrousa, which is this fine fellow over here. And the North Sulawesi Babyrousa, which is again another endangered species. And the Togian Babyrousa, which is this rather charming fellow over here. All 3 of these species are rather endangered, with the Togian Babyrousa only being limited to what I understand a few hundred individuals as well. So what's interesting about the Babyrousa's skull is you can see that unlike other pigs, it has these runaway tusks that basically have to constantly be sharpened and ground, otherwise they will eventually end up growing into the skull of the animal and end up killing it. And this is a case of runaway selection, okay? Usually caused by sexual selection by females, choosing bigger and bigger tusks of their regeneration. Eventually it becomes unsustainable. And what will probably happen in the next couple 100,000 years is that these animals will unfortunately become extinct, because it's not a viable, at the moment they're surviving, but much like a lot of other animals with runaway selection, it's unlikely these species will survive indefinitely. Okay, now let's look at the New World pigs. These are otherwise known as peccaries, and unlike Old World pigs, they are very territorial, and they mark their territories with glands on their faces and their backs. They often live with herds of up to 200 in the wild, so they are quite social. And the American feral hog, which people seem to think is an American pig, is not actually a New World pig. It's an invasive feral domestic pig that was introduced into North America and has gone rampant. Unlike Old World pigs, the New World pigs' canines actually grow downwards as opposed to up. They're also known as skunk pigs or musk pigs occasionally in some areas. So there's only 3 species, and they're mostly limited to Central and South America these days. So the first is the collared peccary, which is this fellow over here. Looks a bit like a guinea pig, no relationship, of course. The white-lipped peccary, this fellow over here, and again the chalcon peccary, which is this guy over here. Despite being slightly smaller and also not having these big tusks, they have been attributed to killing quite a few people just due to their levels of aggression. And yeah, they again play an important part of ecology in Central and South America. Now, the Old World and the New World, I've talked about this before, is a very simple concept. These are just European definitions. The Old World being Asia, Europe, and Africa, excluding Australia. Australia is weird. And the New World simply being North and South America. That's it. There's no difference in it beyond that. New World species and Old World species are different, though, because they've been separated for long periods of time. So we're going to talk about some interesting extinct species of pigs. I always like to include something that's gone extinct. And the first is the entelodont, which went extinct around 15 million years ago. So they're often referred to hell pigs with good reason. And recent fossil evidence shows that they may possibly be more related to hippos and whales than pigs, but the jury's still out. More conclusive studies need to be done. And from their dentition, they were probably omnivores. And this is what he would have looked like. Larger than a short-faced bear, a really big, dangerous creature, and thankfully we don't have to deal with him today, or unfortunately, depending how you look at it. The next is another guy who was found in Central and Southern Africa, Artiodactyl, which went extinct around 2 million years ago, so during the beginnings of the beginning of the rise of man. He was effectively just a large warthog. So compared to a normal-sized warthog over here, you're looking at an animal in proportion to the bones, relatively the same, and but up to 3 times larger. Again, quite a large creature. So suids, or pigs if you want to call them, are critically important to many ecosystems. And they are facultative scavengers, and they play a big role in the waste removal of many ecosystems. In places like Sri Lanka and India, where hyenas have been extirpated and driven out, the pigs have taken up the slack, and they've taken up the slack of vultures as well, with vulture numbers being extremely low. So they scavenge and they clean up all the carcasses and waste material that other scavengers would have taken over for them. And they're also an important aspect when it comes to soil regeneration, and they loosen compaction and create nutrient islands. So if you've ever been into the bush in Africa or India, you realize how hot that soil gets and becomes incredibly baked and hardened, and you're unlikely to be able to grow any seeds in that. And unfortunately, what will happen is most of those seedlings will end up dying, and eventually sorry, my brain's getting distracted. Eventually, the seeds, you'll lose that entire biomass of new seedlings coming through. So when the pigs come through these areas, they end up grinding up the soil, loosening our soil, and actually facilitate the growth of seedlings in the soil. And around their dens and burrows, they also defecate a lot as well. And they create these nutrient islands, I mean, pockets of fecal matter that basically just help seeds to grow in them and help with regeneration of the soil. They're also substantial contributors to zoogenic soil displacement. It's a pretty cool concept that a lot of people don't think about. I'll use an elephant as an example, my favorite example of this. If you take an elephant, it goes down to the local water hole, local mud hole every day, and he throws 10 to 20 kilograms of mud on his back. Every day he's throwing that mud on his back, and he's walking 20 to 30 kilometers, and he's rubbing it off on trees, or it's drying out and cracking and falling off his back as he walks. Eventually what will happen is that lake or that body of water will displace tons and tons and tons of mud or soil material. And you can imagine this happening over hundreds of thousands of years with millions of elephants. How much mud will be displaced in those areas? So that's a zoogenic soil displacement. And entire lakes form this way, rivers get diverted this way, and you turn wetlands into deserts over time. And it is an important aspect of ecology that gets ignored. People forget how much large animals can actually affect an ecosystem, and small animals. Pigs are not as substantial as elephants, but they are substantial. Every pig's throwing a kilogram or 2 every day on his back, and he's going rubbing against trees somewhere else. Gradually, the millions of pigs over hundreds of thousands of years will displace large quantities of soil. And they create access to foods in usually inaccessible areas, like a lot of bulbs and geophytes are in really hardy soil, and even a tough little guy like a porcupine will have a hard time digging them up. Truffles as well, deep underground, and pigs make them accessible to various other animals. Pigs are also highly susceptible to ecological stress and disease, and this makes them ideal indicator species for conservationists. Usually the first things to start collapsing when the ecosystem is sick, if you want to call it that, are the pig species. They start disappearing. And it's an indicator for conservationists just to know that something's not right. Many pig species are able to breed more than once a year and produce litters of up to 12 young. Many pig species also breed in winter, providing many predators with prey items to take in winters when there's not much food around. Pigs got a relatively simple digestive system, unlike camelids and ruminants. It's a simple sac stomach with a cecum and basic intestinal tract. Nothing special, which is actually great because a lot of the seed material they eat, much like elephants and other animals and primates and birds, gets digested without fully breaking down, defecated, and the seeds sitting in a nice layer of waste material and is able to grow. So let's talk about the domestication of pigs. So the earliest records of domestication occurred in Cyprus around 11,400 years ago. And wild boars did not naturally occur on the island. They never got there. And the only signs of introduction were in human settlements, around human settlements and within human settlements. So we have to assume that they were brought across by rafts or small boats 11,400 years ago by humans. So there was some level of domestication already occurring on the mainland. And pigs were also domesticated separately in ancient China around 8,000 years ago. And there's some contentious discussion of whether or not these are two separate strains of pigs or all modern pigs are actually descended from the Asian breeds. Most scientists agree that all modern pigs are descended from the Asian breeds and have migrated across the West, whereas the Cyprus pigs have no modern genetic relatives. So this is a chart over here indicating the evolution of pigs. Pigs gradually evolved in the islands around Indonesia and Malaysia and have spread across the world around 10,000 years ago, 10,000, 9,000 years ago, give or take. Pigs were domesticated in Asia. Gradually, they've diversified into different species, and there's also theoretically hybridization between the Eastern and the Western breeds. So something that's come up a lot lately, of course, is zoonotic diseases. We're in the middle of a COVID-19 outbreak, which is in itself a zoonotic disease, reputedly started by interactions with bats. So what is a zoonotic disease? Zoonotic diseases are diseases that pass from animals to humans and vice versa. So due to animals being kept in high density populations and poor hygiene, pathogens are given ample chances to breed and evolve. And zoonotic diseases can be viral, bacterial, fungal, parasitic, or prions in nature. I don't think you've heard of prions, but we're going to talk briefly about them. I'm not a doctor or a zoologist with any sort of backing in this, so I have got no real formal education in it, so I'll just tell you what I know about it. Okay, so you imagine if you had to put humans into these conditions. It's one thing to go shopping every day in a crowd. It's one thing to go to a supermarket. It's one thing to go to the beach or to a nightclub in a crowd. It's another thing to live in a crowd perpetually, day in and day out, and interacting with tens of thousands of other individuals persistently and constantly all day and all night. And this is an ideal breeding ground for bacteria and for other microscopic organisms. Likewise, if you had to keep pigs in these sorts of environments where you're literally cramming them, as much as possible into conditions, they're living in their own fecal matter, their food is rotting amongst their feet, and they are, there's really not much to, in terms of care given to the animal. I mean, this looks sterile, but it's certainly not. I mean, no human will want to live in these conditions. And likewise with pigs. I mean, this is supposed to be free-range farming as opposed to battery farming, and it's still, I mean, no human being should have to live in these conditions. This is a South American prison, by contrast. Imagine if you had to grow up and live in these conditions with the sheer number of humans literally sleeping all over each other and each other's filth and diseases. You can imagine how diseases would run rampant. And we wonder why we have so many diseases coming from factory farming. So I always advocate to people rather buy venison. It is a far healthier alternative than meat. In South Africa, it's cheaper, much cheaper than farm meat. And also it's healthier for the animal. It's just more environmentally friendly. And it's also, in my opinion, more sustainable than intensive farming. So those are zoonotic diseases. And talking about bacteria, there's quite a few bacteria. I'm sure you know the first one very well. Salmonella, you don't get it from salmon. Okay, the Black Plague spread from rats to humans. Anthrax, which is, occurs a lot of the times in the bones and the fecal matter of predators. You don't ever pick up bones if you're in the Kruger National. Brucellosis, which is a neurological infection, but can also make its way to the skin. Leptospirosis, which is this over here. This causes scales all over the body. And again, I typed brucellosis because I made a spelling error. Okay, viruses. We've discussed what viruses are. They're not the same as bacteria. HIV is the most well known. HIV came across from chimpanzees to humans reputedly in the early 1900s and was in Africa for well over 80 years. Africa had documented case of HIV in the 1950s, if they've actually gone back and looked back at the old records, but it made its way into North America in the 1980s. Okay, there's even evidence to suggest that HIV may have been prevalent in Africa and North Africa and even the Middle East as far back as the 1500s, based on descriptions by the doctors of the patients back in those times. COVID-19, we all know and love. It's hitting us hard at the moment. And rabies, affecting cats and dogs and everyone worldwide, another viral infection. Yellow fever is not just something that you get, there's a whole joke about yellow fever in Asians. No, but it's something that occurs it's prevalent in East Africa, and you have to get vaccinations for it if you go to East Africa. Swine flu popped up in Asia, as did bird flu, from also keeping these animals in large numbers. Ebola popped up in Central Africa initially in the 1950s, if I remember correctly. Parasites can be single cellular or multicellular. I'm not even going to try to pronounce half these names. I'll try the first one. Angiostrongliasis, Anisakaiasis, Baleocellula, whatever. I'm not going to pronounce the rest of these names. They pay doctors to say these things. Okay, so nevertheless, they can have horrific effects on the bodies, and toxoplasmosis, which is my favorite example, turning rats into zombies. It occurs in the fecal matter of cats. The rats will eat the fecal matter. It affects the brain chemistry of the rat. The rat loses all fear of the cat and will often end up running towards the cats and get consumed, and again affecting a new cat, and the cycle continues. So parasites also affect humans. They've shown they have neurological effects on humans and can have all sorts of horrific diseases occur. One woman in China noticed that she was having these aches all over these bodies and these neurological issues, and she went in for an x-ray and she discovered her entire body infested with worms from consuming too much pig meat, undercooked pig meat. So yeah, enjoy. Fungi often affect our lungs. The one is cryptococcosis, which is a fungal infection that can occasionally make its way to the skin and cause these rashes and lesions all over the skin. And the other one is histoplasmosis, which if you've ever worked in animal rehabilitation, and if they have a bird that suddenly dies for no reason, when they do a necropsy, they'll insist that you wear a mask because they often have spores inside the lungs that can be extremely toxic for the body. Prions are simply just misfolded proteins. And I don't understand exactly how they work. Again, I'm not a doctor specializing in this. The most well-known is mad cow disease. And the thing about prions is that you can't destroy them just by cooking them. You have to really completely obliterate the protein in order to stop it from functioning. And it started off, as far as I understand, in the UK from feeding these cattle all the sorts of mixed up weird protein-based meals. And it rampaged through the populations. And you can't even cook it out of the animal. You have to burn the meat completely. And even with burning, some of those prions still survive. So there's no way to consume this meat healthy. It has to be completely obliterated. Occasionally, it does evolve into a human-based form and becomes the Creutzfeldt-Jacobs disease, and it is a 100% fatal neurological disease. It gets into your brain and causes complete shutdown of the brain, and you will die from it. So yeah, mad cow disease is frightening stuff. So these are zoonotic diseases, and something that we should take note of, something that we should, when we're approaching, obviously our issues with overpopulation and obviously the way we're farming animals, we need to go forward and reevaluate and rethink the way that we handle our farming. Not necessarily say you're going vegan or vegetarian, but if you're going to eat meat, we should be far more conscious of the way that we actually farm, and can't just throw a bunch of animals together and hope for the best. On that note, thank you very much. I hope you enjoyed the class, and going forward, we will try, as always, to try to take it to 2 classes per week. With my schedule, we're going to be keeping it to 1 class per week for at least another week, I imagine. Okay, thank you so much. I will see you guys at the Q&A. Ending.